All right, folks, Phil Zito here, and welcome to episode 19 of the Smart Buildings Academy TV. And in this episode, we're going to be going through floating control modes. So if you don't recall, in the previous episode, we were going through on-off control modes. And we're going to be utilizing what we learned in that episode in this episode as well. Okay, so here's what you can expect. We are going to go over to the whiteboard. We're going to talk a little bit through on-off control, and then we're going to talk through floating control, and then we are going to look at some programmatic aspects of things. Like I said, I'm Phil Zito, CEO of Smart Buildings Academy, where we help companies and individuals develop their skills in building automation so they can go and advance in their careers and grow their businesses. All right, let's move over to the whiteboard. Okay. Hey folks, so like I said, we're going to start by talking about on-off control, and then we are going to move through floating. So if we recall, on-off control, also known as two-state control, has two states, right? It's either true or false. And that is our kind of building block of a control mode. So when we're talking about floating control, what we are typically talking about is specifically an actuator that we are driving with one clockwise command and a counterclockwise command. So we are typically utilizing these actuators for hydronic control on kind of like terminal units and fan coil units, units that are high in count, but are more tolerant of not having the, I don't want to say accuracy, but the precision of proportional control, because a proportional actuator controller is going to cost more than a floating control actuator controller. All right, so how it works though is pretty much the same as proportional control, but it utilizes on-off control. So we're going to have a process variable, and we're going to have a set point, and that is typically going to either go into a PID loop, or it's going to go into a floating controller directly, depends on your programming language. And then from that PID loop, it's going to come out as an output, and it will go into a floating block. And this floating block will drive a single DO or BO on, and we'll have a DO off. The important variables we need to understand for this are our stroke time, our actuation time. And that is how long does it take the actuator to drive from 0 to 100% and from 100 to 0%, because the float block is going to track that, and then based on it tracking that, it's going to know where the actuator is, and it's going to drive the DOs accordingly. So like I said, you're going to have a clockwise and a counterclockwise DO, and you're going to have a shared common, and it'll just switch, it'll float between the two DOs. So pretty straightforward control, but something that is used all the time. I feel like from a controls perspective, a lot of folks focus on things that are overly complex. If you just get on-off control, PID loop control, and floating control, and sequenced control down, those four, you will be able to handle almost 90% of the things you're going to experience out in the field. Because on-off control is going to be, your fan commands, it's going to be your electric heat commands. Sequenced control is going to be like sequencing up chillers, sequencing heat, etc. Floating is going to be for your terminal units, your fan coil units where you're using hydronic heat and you want to have a low-cost actuator. And then PID control, that's actually both going to drive proportional outputs, but it's also going to drive a lot of these blocks. Like the PID block is going to drive floating and sequencer. And we're going to talk about PIDs more in next week's video. So I'm going to move back over to the computer real quick, and we're going to talk through kind of programmatically what this looks like. I was not able to get my hands on an actuator in time to record this video and show you kind of how you wire it up. But I mean, it's really, really simple, right? It's coming out of a controller, right? Out of this controller. Let me make sure this is still in frame. Okay, it is. And then we're going to have DO, like DO1, common, DO2. And at the actuator, you'll have DO1, common, DO2, and you'll switch between the two. So that's how it works. It's really straightforward. All right, I'm going to move back over to the computer real quick. Okay, I'm going to share my screen. I'm going to transition to that real quickly. Hold on here. Let me just kind of shrink that. Just got to do a couple of transitions real quick. And there we go. So we should be good now. You should be seeing my screen. Okay, perfect. And with my screen, we are going to log into our SoftJace here. We're going to go to our config, drivers, backnet, and we're going to go to this spider device. Actually, it's just going to be easier to go to it this way. And we're going to open it up. We're going to step into engineering mode. We're going to look at our binary output right here, and we can see, oops, double clicked on that. We can see this is just a straight up binary output, DO. But if I go to my modulating output here and I go to properties, right, and I set this as floating, it's going to float. And it's going to float between the values. And so all I would have to do is input a 0 to 10, and it's going to float. And we can kind of see how this all works. I've got my travel time, and based on my command, it's going to go and float between my two DOs. Pretty straightforward. So I would just, put in a loop block here. So let me get the control, PID, blow this logic out of there too. Zoom in a little bit here. But it'd just be my output of my PID to the input of my floating block right here. And the PID would directly drive it. Some other software, if I remember correctly, it's been a while since I programmed Allerton, but Visual Logic and Allerton would require you to input into a floating block and then connect that floating block to DOs. Some other logic does that as well. So it just really depends on your logic. But at the end of the day, it's a process variable, most likely into a PID loop, either into a floating block filter, which feeds DOs, or directly into DOs, which are set up as floating. And it's just a DO array. And what I mean by an array is it's a collection of DOs, DO2 and DO3. So you can see that right there. This is pretty straightforward stuff. Not a lot for me to dive into here to be fully transparent. But that being said, I will answer any questions you have about this, so feel free to ask, and I'll answer the questions as they come in. Like I said, in next week's live stream, we are going to be looking at sequenced control modes and PID loop control modes. And I may actually collapse the sequenced control mode into the same video as the PID and then spend 2 videos on PID. And I would spend one video going through kind of how PID works. And then the next video, I would go through kind of more advanced, like how do we get throttle range? How do we get integral time? How do we determine those values? How do they work? And what are kind of things like biases and step values, and setting output limits and input limits on PID. Ramp blocks going into PID for kind of like morning startup, where you wanna ramp the block or the output itself. Which personally, I'm not a big fan of using ramps on your PID loops. If you have to use a ramp, then that usually indicates some greater system issues that you're trying to go and substitute for with a ramp. What I mean by that is, let's think about when you would use, man, I'm going so off the rails here. I haven't even taught you all PID, and I'm starting to talk about ramps. I'm going to pull myself back here because I haven't given you the prerequisite knowledge to go and start talking about using a throttle and using ramps to basically slow down your PID loops in the case of like morning warm up and not wanting to shock the DP in the air side of things. That being said, though, hey, any questions, feel free to ask. I hope you all were able to catch the controls engineering webinar today. If you weren't, I'll share a link to that real quick in the comments. Let me go and grab that, and I'm going to put that in the comments. It's YouTube, and you just go and you click and you watch it, and it's like an hour and a half, hour 15 minutes. It's really good, dives into engineering. Don't leave the live stream just yet to go watch that, but yeah, I'll remain, see if you all have any questions. In the meantime, hey, thanks for attending. I'm always glad to have you all here. As I mentioned in the previous live stream, your feedback is key as to what we cover. We are going to be covering sequence control modes and PIDs over the next 2 classes. Then we're going to be diving into network basics 1 through 3. And then we're going to be diving into BACnet basics. So, is 0 to 10 volts preferred over 2 to 10 volts? So here's why folks use 2 to 10 versus 0 to 10. So if you think about 4 to 20 or 2 to 10, right? The reason you're doing that is that if you go and you have 0 volts, but your output is set up as 2 to 10, you have a failure mode, failure detection built in. That's why you use 4 to 20 instead of 0 to 20, and that's why you use 2 to 10 instead of 0 to 10, because that failure is built in. So if I go and I meter an output that's a 2 to 10 volt output, but I've got 0 volts coming out of it, then I know something is wrong with that output, because even at 0%, that output should still be 2 volts. So that 2 to 10 volts gives you, it gives you an aspect of troubleshooting. So good question. You more so see that, by the way, on, oh my gosh, I just lost my train of thought. My goodness gracious. It's been a long day. I did an hour-and-a-half webinar, like 6 videos for our engineering bootcamp course, and now I'm doing this live stream. And my brain power is escaping me, saying, old man, it's time for you to go to bed. So, but yeah. What other questions can I answer for you? Good question, by the way. Give it a minute or two. Just seeing if anyone anywhere else has asked any questions. Somewhere in the social sphere. Okay. See it on VFD with signal failure mode. Yes, that is absolutely correct. You do. Can I explain why stroke time is important for floating? Yes, I can definitely explain why stroke time is important for floating. Okay, so let me go back to the whiteboard real quick. All right, we're going to transition over there. Okay, so you've got this actuator, and the actuator itself has the ability to drive it clockwise and counterclockwise. But the problem is that unlike a proportional actuator, where you're going to go and drive the actuator and kind of all that timing and everything is built into the actuator without getting into the specifics, you don't have that built into the actuator. So the actuator itself has no real way of knowing where it's at. And because of that, when you go and you drive your DO to hit 50% or 60%, it's a calculated value. So the floating block kind of keeps track of where the actuator used to be. And then it says, okay, if the actuator's at 50%, then that means it's stroked for 45 seconds. And if I want to take it to 75%, then I need to stroke it for another 22.5 seconds to clockwise. If you don't know that stroke time and you don't have an accurate stroke time, then when you engage that clockwise command for another 25 or 22.5 seconds, then what will happen is you may actually overdrive it or underdrive it because you're turning on that output, either the clockwise or the counterclockwise. You're turning those on for either shorter or longer than they actually need to be on to activate the actuator to the position it needs to be at. So that's why stroke time is important for floating, because with a proportional actuator, that's all kind of built into the actuator. But in order to save money with floating actuators, those electrical components do not exist. So you're just relying on a pure drive the damper one way, or drive the motor one way, drive the motor the other way. So that's why it matters. Okay. I'm going to switch us back. Alrighty. So what other questions do we have here? We'll give it a couple more minutes just to see if any questions filter in. And we'll go from there. Should you continually drive the actuator open at 100% and close it at 0%? Or shut the output off when you reach the 0% and 100% limit? Where do you find the stroke time for the device? So stroke time for the device, I'm going to answer that question first because that one's easy. And then I will answer the question after or before that. So Belimo floating point actuator. I'm going to bring that up. Let me transition over so you guys and gals can see my screen. Let's go here, on off float, and it should say, there we go. Where's its full stroke time? Here. Brushless motor. Did I go past it? They have so much on here. Let me take a look. Here's a nice little write-up about it, by the way, that I'm gonna put in chat real quick for those of you who want it. Which you can kind of see. Where's float? 3-point float, right? One drives to open, the other drives to close. If there's no signal, then the actuator simply stays in its last position. But where was the timer? Did I go past it? I could have sworn. 150 seconds is the motor runtime, constant, independent of load, but that's not what I'm looking for. I'm looking for the stroke time. And I feel like I'm missing it. It's normally 90 seconds to 120 seconds. On-off floating point string return. My brain just tired and I'm looking at it and just completely missing it, which is probably what's happening. Yeah, so it must have been 150, because this one I know for a fact is a 95 second, and it's 95 seconds. So yeah, right there where I showed you earlier. Where did it go, by the way? There it was. 150 right here. So it depends. You just go and you find it, and typically somewhere between 90 to 120 seconds. Some of the larger ones will get up to 150. Now, Chemo, to your question. No, that wasn't Chemo's. That was sorry, this is really small text here. Widget. Widget? Yeah, I think so. To your question, you only command the on and off, so the clockwise and counterclockwise. You only command those when you are actuating the actuator. If you're not actuating the actuator, so let's say you drive it to 100%, then you turn off the command. If you drive it to 70% and it's at 70%, you turn off the command. And then that floating block is supposed to remember where it was last at. Can I give a quick rundown of the steps I would take to troubleshoot a floating actuator? Yeah, sure. So what I would do to troubleshoot a floating actuator is, first things first, I would make sure that it is actually working. So I would make sure that it's got power when I command it on to clockwise and power when I command it on to counterclockwise. And I would test those at the controller, and then I would test those at the actuator. Then I would, while I'm testing at the actuator, I would make sure that the actuator is still attached to the damper shaft or valve stem, whatever, depends on what we're doing. Then after I've tested that, I would make sure that my timing is correct. Those big three things right there are going to solve the majority of your troubleshooting issues. If you test those three things, you will most likely find the issue. It's usually going to be either timing, or like the common came loose, or the actuator itself came loose from the valve stem or from the damper shaft. Those are kind of the common things you're going to find. So yeah, good questions. All right, I'll give us 2 more minutes for questions, and then we will call it a night. Man, I gotta get some new contacts. My eyes are starting to dry out. Okay. So not seeing any questions, I will give us 1 more minute and then we'll call it for the rest of the night. All right, cool. Nuts. Oh, look, right when I was about to say cool. How often should you calibrate or zero your floating control? There's usually 0 on start, so whenever the actuator itself, or sorry, the controller itself starts off, it'll do 0. You can also see, like, if I go here and I go to advanced, I can go in and set kind of my failure detection. I can set in my auto sync if I wanted to. How do I do that? I could set my interval for auto sync. Oh, I'm not sharing my screen. Hold on 1 second. There we go. So I did provide the link in chat that I mentioned for the Belimo thing. But yeah, you can see kind of right here the auto sync type. I could say I sync it to closed or I sync it to open, and I can say how often I do auto sync, like the auto sync interval, and I can say what I want it to sync to when it powers up. This is not necessarily true for every controller. This is just a Honeywell Spider controller I'm looking at. Not everything has auto sync built into it. Some actually require you to go and run a sync yourself. There's actually you can kind of see it right here, sync edge trigger. So on the output itself, you would connect to that, and maybe every time it switches state from occupancy to to unoccupancy or unoccupancy to occupancy, you then go and trigger that sync. So there's a variety of different ways you can do this for different controls. Okay. Well, with that being said, we'll call it a night. Thanks a ton for everyone being here. I hope you enjoyed it. I look forward to seeing you next Monday night at 8 p.m. Central Standard Time. And we'll be talking about sequenced control and PID loops. Thanks a ton for being here, everyone. Have a great rest of your night. Take care.